You probably heard about data lake, but do you know the term device lake? That's an interesting concept that Jonathan Beri introduced to me while discussing device management and other things that the Golioth IoT platform offers. So Jonathan Beri created Golioth, among other things. He has a vast experience in the world of IoT, and he's coming to the IoT Show to share not just his experience, but explain the concept of device lake. Hi everyone, this is the IoT Show. I'm Olivier, your host. Jonathan Beri is joining me today to discuss device management. And so, Jonathan, before we get into the interesting topic, who are you?
Hey, Olivier. Thanks for having me. My name is Jonathan Beri. I am the founder and CEO of Golioth. I've been spending the later half of my career in IoT just because I love it and fascinated by its intricacies. The things that make it hard is the things that make it enjoyable. I'm sure we'll talk a little bit more about Goliath, but started really digging into the space when I was at Google when we acquired Nest, and I got to work on some early embedded software developer programs and have been at different IoT roles prior to starting Goliath over almost 4 years now.
So we talk a lot about industrial metaverse, digital twins, AI. They all have one thing in common. They all need data. So where is that data coming from?
Yeah, it's interesting because our space in IoT, we sit between devices and device teams and device and hardware engineers, for example, as well as cloud and data engineers. And really the conversations with the cloud and data engineers is, well, if I just had access to all this information, I could build these great models and predictive maintenance, et cetera. But you're spot on. That data has to come from these devices. And I almost have to re-educate the cloud teams of saying, hey, the device is actually super critical to enabling you to build your metaverse, your digital twin, your predictive maintenance. And if that's not working right, if the data coming from those devices are not structured correctly or reliable or maybe even coming when you expect it to come, well, then all that vision of using that data is impossible. And so I like to say you got to start with the devices to get the data so you can build your IoT product and vision. So it comes back to devices always.
So it does start with the data. It implies now that you need to connect these devices. But now they're connected, there's a new dimension to dealing with these devices, which is their management. Their life cycle, their updates, and we're talking about AI, digital twins, things that will require software running on these devices to be updated. I'm not even mentioning security. So, what is your stance, your perspective on how device management has grown, has evolved, where it's at today?
Yeah, well, it's definitely evolved, and it didn't really exist a decade or so ago. The strongest parallel, actually, when you had Rob on, was talking about mobile device management. And so, the world of smartphones, we thought we could apply all the lessons and learnings and infrastructure from smartphones to IoT devices, which was probably a good first pass at it. But the domain of IoT devices is so different. The nature of the devices, who owns them, where do they run, what kind of hardware do they have? And so it's really been this sort of, say, from my perspective in the career, translation from the world of MDM for devices to really a new form of device management for IoT. And, like a lot of folks, you start with a web server that can speak HTTP and some open source code here and there, and maybe some libraries you found on GitHub. But it's really when we talk about device management, we're talking about enterprise grade systems that have security at the forefront, how to think about scalability, how to manage different packages, the heterogeneity of devices, ultimately all of that, which kind of is as important as the security and reliability, but to generate just one bit of data, literally a byte, needs all those things to happen. And so I would say that the IoT infrastructure landscape has been investing a lot in a lot of companies and software and and just lessons to figure out how to do IoT device management so that we can actually use those devices in the field.
So, Jonathan, device management is a necessity. It's there, right? But it does not generate value per se. It is, this kind of things where you have to have it, but it does not generate value. Is it something that you're observing, and do you think it has an impact? The fact it doesn't generate value, does it have an impact on how customers, how enterprises in needing these IoT solutions are deciding to go about it, right? DIY
Yeah.
versus buying a solution off the shelves, everything in between.
Yeah, and there's a couple topics to unpack there. For enterprises who are building maybe their first device or their first connected device, they actually don't think about device management because they're thinking about their solution or their customer need, and what kind of sensor do we have? What's the form factor? So oftentimes, device management isn't part of the original product requirements, which obviously has costs and complexity associated with it, but actually could require a completely new product to be developed. So, for example, just for a concrete example, if you're designing a device that doesn't have the ability to be software updated, you might not have enough storage on the device to do a software update. Um, I've seen this many times where someone actually has a product they're starting to manufacture and then thinking about device management, and they actually have to respin the entire product because there's not enough flash. And so it has those important elements to be discussed from the very beginning, which also has implications of who do you partner with, what kind of cloud are you using for enabling that. But there's also compliance and legalities that are now starting to happen around the world. Things around security for IoT devices is being legislated or either strongly recommended. Here in the US, the FCC is now requiring a label for security, and different countries have different requirements. And that's everything from consumer devices to commercial and enterprise. Things like pipelines, for example, should probably have really good security. And the if you actually read into what those requirements are, they actually include things like software updates, things like the ability to rotate passwords or credentials. And so the concept of device management has to be in the forefront of discussion. Yet, to your point, it's actually not usually something that's part of the end product's revenue or part of being able to monetize the asset or the use case. So it's tricky because if you're going to spend your time and resources designing a compelling product or a new form of revenue, you want to focus on things that actually generate revenue. And so the shift now is, especially for companies who either have learned lessons in the past or maybe they're engineers or product owners who've actually seen this play out in other organizations, they actually start thinking about device management, device components, sort of the fundamentals at the very beginning, and trying to decide how quickly can they either build something in-house or build versus buy. And a little bit about where we sit in, that part of the stack usually is an easier conversation to have, to buy, right? So you can partner with great software vendors, find other solutions that maybe include device management, but it usually has to happen in that early phase. And more product owners in particular are starting to think about, well, what happens if I have a security vulnerability? What happens if I want to push a new algorithm? And so that's actually now being included as the set of requirements and the evaluation in when they're just building out their idea for the first time.
Yeah, in an earlier stage, they're starting to learn. It's good for me, right? Because that gives me some business to go and advise people on what to do and how to do it right. It's good for the IoT show because that's the overall message I want to send out with all these discussions I'm having here. I'm lucky to have like people you spending time here. It's really about how do you do it right, and doing it right is planning ahead of time, understanding what you'll need to do, and so on. So you're describing the lessons you learned over the last decade or more, actually, because you've been in that domain for longer than that. So you were mentioning the fact that customers they talk more and more about data first, right? So data is the thing that they need, right? And that's what they're interested in. And sometimes they do the shortcuts, just like picking, hey, that thing's going to just send the data, and I'm good with that, without realizing the need for that device management. So they connect the devices, they end up with that situation of like, oops, I need to do something about it. Regulations are catching them up and so on. So you learn that, not the hard way, I would say, but in real life.
Mm.
Another thing you brought up when we were preparing and discussing is the notion of device lake. So that's something that I don't know if it's an industry term, something that you coined. Maybe you coined it, and maybe that's
Yeah.
the first time we talk about it.
Yeah, yeah.
Tell me a bit
I will
about it.
take credit for it, or maybe blame. Or I'm trying to make it a term just to help quantify the opportunity about data. Um, and for those who are familiar with the term, a data lake, it's a very common set of data services. Right? Big companies like Snowflake have built their business around being a place to store all the data about your business, about your customers, about your e-commerce, whatever, so that you can create insights. And so the actual value of data only happens once it's in your data lake. So anyone who watches the show who is in any form of data is like, oh yeah, of course I know. That's where I can actually build our algorithms, et cetera. And the point of this sort of cheeky term device lake is that all the IoT value is actually on the devices. So the data itself, which is living in the physical assets, is not in the cloud. And if it is in the cloud, it might not be in the place where it needs to be, like a data lake. And so this usually part of the digital transformation conversations we have with our customers is you're trying to use this device for some use case. Well, really, what's the core business opportunity if this thing is just spitting out data? So a lot of times, someone will get to us, a device that maybe is monitoring a compressor or tracking some sort of tagging trace, and they're just focusing on the one thing, like the position of the device, or is this on or off? But the actual engineers and the data scientists and the business stakeholders who are trying to use that data can't do much with that. But this device is generating all this sort of sensor readings and positional information, et cetera, and they're throwing it away, not because of cost, because they don't know how to get it to where it needs to go. They don't know how to get it to the right teams and to the actual data lakes. And so the idea of this device lake is, well, actually, if we can tap into all these devices and use the data either on device, at the edge, or in the cloud more effectively, well, then we actually can realize the vision of all this IoT data creating new value. And so it's almost flipping on its head. Like we should tap into the lake and stream it to the cloud. But it's something that becomes an aha moment when we start working through use cases and applications of once you've built a connected device, once it's managed and streaming, what can you unlock once it's in the cloud?
Yep. And I like this notion of device lake and the way you're describing it. And because the evolution of that domain of embedded and IoT has been such that it's still complex, it's still hard. And we're all trying to, at the beginning, we're all trying to abstract it like at a super high level, like way too high level, building SaaS offerings, having a one way for every device to talk to the cloud or whatnot. A single protocol should win or whatnot. But at the end of the day, it's just not the way it works. I like this notion. When I think about a data lake, I think about the abstraction when it comes to the complexity of the data structures, data types, the various services to access it, SQL, NoSQL, and so on. A data lake to me is something that also abstracts that and offers an ability to query that data and leverage that data independently of the type of data, independently of the format, and so on. And so device lake, we know devices are all like super diverse and talk different languages and are compatible with whatnot field bus and so the notion of device lake, I like it. It's really you have this resource down there, and yet there are ways to extract the data, OPC UA and in MQTT and CAN and BACnet and Modbus and whatnot. And
Yep.
but you should not, as the one who needs to use the data, have to care about that. Okay, Jonathan. So let's see how you approach this problem space of managing devices and connecting them, and having in mind the various people who are engaging in this kind of solution developments. What has been your approach for Golioth? How did it evolve along the years? How are you tackling this device lake concept with Golioth?
Yeah. So maybe start with our tagline, the universal connector for IoT. Because we actually don't call ourselves a device management company or a data routing company. Really, the connector piece. And when we engage with a customer, we usually talk to three different groups or three different people. There's the hardware team, the ones who are responsible for building the thing.
Mhm.
There's some form of cloud team, sometimes data, sometimes analytics, sometimes application. And then in the middle is this product owner. And when we talk to the hardware team, they have all these pressures because they can't even prove out their business until they actually build a thing to validate that the thing can be built. And they almost look at the cloud side of the house as adversarial. they're putting all these requirements of this format and this cryptography. And all I want to do is send the little bit of data they need so I can focus on actually delivering on the hardware. I just want a serial port to the cloud, and so I don't have to think about it. And then when we talk to the cloud folks, they have a similar kind of opinion. It's like, I don't care about devices and flash memory and 3GPP modems. To me, that device is just JSON. Can I just get a JSON blob so I can go out and build the applications we need to build? And in the middle is the product owner, because the product owner feels, I'm trying to deliver business value. We're trying to create revenue or sell to customers. No one buys device management or databases, right? They're buying comfort, safety, predictive maintenance. And the truth is, we need to enable both of those engineering teams to be successful, and that product owner to really be able to guide the product to market faster. And so when they're drawing their architectural diagram, right, they have devices that they're building over here and all the systems and their ERPs. There's a little Golioth box, a little giant, if you will, that's connecting the glue. So they never have to think about getting the devices to send the data to where it needs to go, or how to consume the data from those devices. So sort of the middleware between the organizations. And the journey for us was, we started building out a pretty, I would say, flexible system. Lots of different types of devices, different types of technologies, and protocols and connectors. And as we went to market, we saw two groups of teams, especially on the engineering side. Ones who are like, okay, so use MQT, what version of MQT, what format can I support, what libraries can we support? And the other one's saying, I got a temperature sensor, and I got to update that sensor. Can you help me solve this problem? And every time we had the latter conversations, where we weren't mired in the hard parts of IoT, like protocols and firmware, we actually saw more success. And so we started to take our very flexible system, which is still that flexible today, and make it more and more opinionated. And the more opinionated we were, the easier it was for engineers to actually build. We had to change some things and think about, okay, well, what are the challenges that are important, like flexibility on programming languages or a system architecture, and which connectors they can connect to. But sort of the middleware piece became optimized for specific IoT use cases. So, for example, being able to store data into a database and then synchronize that data down to the cloud, that's actually a pretty common problem across all different applications and use cases for IoT. And it's still hard, right? Like, if you want to change a setting in the cloud and then send that over a cellular network and then make sure it gets delivered onto a tiny microcontroller class device and then verify that happened, all the while managing battery and connectivity and bandwidth and your SIM plan, like, that just needs to work. And so that's where our sort of hard engineering challenges work. But at the end of the day, the hardware team just has a simple API to store a setting, and the cloud team has a simple API to update that setting. And so what we found is this balance, and really why we embrace this middleware as a general category for us, so that architectural diagram is just Golioth in the middle, and then all the other problems you have to solve for are still at your disposal and under your control. And so that's a lot of things. That still could be a lot of things. And what we found was there are industries and technologies that highest value, highest complexity. I've spent a lot of years in IoT, worked on mesh networks and Wi-Fi and Ethernet. And cellular is one of those things that are particularly challenging. Cellular, working with cellular devices, cellular networks. But it also turns out places where cellular gets deployed the most, where you're reaching for cellular, tends to be the most valuable, whether it's because the asset is moving or the environment is very complicated, or it just the nature of the business says, hey, we can't use other technologies, we have to use cellular. And so we actually have a lot of expertise in helping customers build cellular connected devices for things like track and trace, remote monitoring, tracking concrete foundations for buildings. And we've developed more expertise along the way, but that's really how we focused our energy. We built this middleware that's optimized for IoT use cases for helping hardware teams and cloud teams collect that data in specific ways. And the areas where there's the most challenge, where we see the most interest and growth is around cellular. So that's a general high level about Golioth.
Yep, no, I like it. I like the way you're presenting this notion of middleware. It's going to be definitely resounding or making sense for developers of both sides. The ones on the device side of things who are familiar with the notion of middleware or frameworks to access a certain level or types of functionality. And on the other hand, the developers who are like .NET developers, or developers that for them is like, what do you mean I have to redevelop that? There must be a library up there that I can just like inject and use and add to my stack that is my new middleware, my new set of resources here. I also appreciate this notion of being opinionated, because we won't get anywhere if everyone has, I wouldn't say it's not a matter of everyone having their word or not. It's we need to get to a point where things are working, and things
Yep.
will fall in place, and we'll end up dealing with that. And there are, to me, and I'm curious to have your opinion on that. There are enough industry standards existing today that are in between the realm of embedded up to the realm of edge compute and then to the cloud, that we can build on top of them, and it's not a matter of one either or another one. It's more a matter of like which one to be used in which situations, and
Yep.
having that
Yep.
strong opinion about, hey, I'm going to build that stack in between, addressing these number of scenarios, and like I'm going to implement it the way I think it's the right way to do it inside, right? So I
Yeah.
don't know if you
Yeah.
share the same perspective here.
I mean, you're giving part of the pitch for Goliath and how we started the company to investors. The best piece of advice. So I've been working on developer platforms my entire career. Um, Best piece of advice I got from was the actually one of the CTO, a former CTO of Firebase, and he's like, yeah. I asked him, how did you crack the nut for developers, and how did you become a very successful developer first product to ultimately get acquired by Google? He's like, um, we actually built a different product before, and it was very higher level. I think it was a chatbot, and it was a chatbot with APIs, and developers could use it. And this is when chatbots were really popular. But no one was really using the chat feature, and they kept on asking us for the synchronization capabilities. So they pivoted. They built more like a pub nub type of synchronization that you could build a chatbot or you could build something else, but it was too complicated. And they got feedback again of their earliest customers saying, it's low level and I have to think about state and where do I store the thing. And so then they built a real-time database. And that was the right level of abstraction for mobile developers, because it gave them some APIs where they can choose how and flexibly they want to model their data, but they didn't have to think about parts of the system. And that's really what drove the direction and continues to drive us today of finding the right level of abstraction for IoT developers, whether the IoT developer is designing the hardware, or they're designing apps or mobile, or they're the product owner who has to think about the architecture from the beginning. And we built on a ton of open standards and open source, and we will continue to do that and contribute to that. But finding the flexibility of where it matters, like I was saying, someone cares about a specific version of MQTT, maybe they're optimizing for something. But if they don't care, right, they have performance requirements. I'm on a cellular network, and so I need to have this much budget for my battery and this much bandwidth available. As long as it checks the boxes, then it helps them build their product. Um, but
Yep.
for example, if you said, "But you must use this particular device, or you must use this particular carrier, otherwise we can't make it work," that's the wrong level of abstraction, at least for our customers. So finding the right mix of um, areas where you need that flexibility, you need that, or you need that control, and then partnering and adapting existing technologies is kind of the key. We can go into the details of how Goliath is built, and we've published all of those details as well. But the moment someone asks about what version of Go are you running in the back end, they're thinking about the problem at the wrong level.
Device lake is about any kind of device that are there at the edge, but there is a multitude of them, right? There's like goes all the way down to programmable FPGAs and this kind of stuff, very, very low level, to MCUs, MPUs, and also now gateways running like full CPUs, and
Yep.
sometimes servers. And so this is a very broad landscape of edge devices, or what people call IoT devices. And everyone has their own definition. This is IoT, this is not IoT, this is heavy edge, this is light edge, this is tiny edge. This is like, ooh. So from your perspective, you're opinionated and you decided that Goliath would address a problem space. What is the expectation, for Goliath to serve in terms of what kind of devices you guys support today?
Yeah, I won't enter the territory of definitions, right? That's totally tabs versus spaces. And we actually don't even use the words of IoT very much in our marketing because that's not what we're trying to solve for. It's a little bit in our name. It's kind of hidden in there. But the we did that quadrant, which I'm visualizing with my hands, right? Where is the most challenge, the most amount of data, and the most opportunity for commercial value? And so for us, it's really at the far edge. Um, Again, definitions, but sensors that are running on, around microcontrollers, that may have different kinds of radio technologies around it. But ultimately, that's like the core problem because it's closest to where the data is being generated, the atoms to bits conversion. Um, the gateways and more of the industrial, PCs that are servers. We don't play in that space. We actually have partners and friends who do. You had Mark from
Yep.
Belina previously. They solve for that problem, and we solve for those very far edge devices. And it's a completely different set of skills, different set of partners and sort of ecosystem, right? Like we work with great microcontroller and radio RF chipset companies to enable our SDK on top of their platform, like Nordic Semiconductor, NXP, Infineon, and a bunch of other ones, which is a different set of relationships you have to go build if you're trying to get your software to run on devices. I think where it starts to converge is when it gets into the world of pure cloud, right? And we work with the Amazons and the Microsoft of the world, as well as data visualization tools like Ubidots and Data Cake, because once it's in the sort of that threshold, it's all data. It's all JSON data. It's all Kafka streams. But that translation layer requires a very specific set of technologies and skills and standards and partnerships. So if we were to hone in on, really, we help generally this sort of class of microcontroller class devices that are typically sensors, though sensing also can mean like a door lock or a scooter unlocking, but that class of device.
Yep. The industry trend, especially you were talking about the hyperscalers, I'm seeing them. I'm coming from one of them, right? Everyone knows, was part of the Azure IoT team, and the latest announcements from the Azure IoT team go along with the previous announcements from Google, IBM to pull out of the specialized IoT services hosted in the cloud. And Amazon still had a strategy that was very much around green grass, and this notion of having an entity. And that's what Microsoft is doing with Azure IoT Operations as well, bringing an entity which is an extension of the cloud on premises, but leaving to the ecosystem that last mile, I would say, which is complex, which is specific, which is these devices that will need to have this management layer. Is it going to happen from a cloud entity directly to the devices? Is it going to go through a local, on-premise instance or proxy to a solution like Golioth? I'm convinced of that. I'm convinced that these hyperscaler will extend their cloud to the premises onto entities that will be able to run agents and so on that are compatible or whatever the other solutions are out there. And there is a play for playing nice with them because, yes, once you've been massaging the data, massaging the data and putting in a format that is consumable by cloud entities and resources, this can be taken care of by the hyperscalers. And so, focusing on these tinier devices, I think is the right approach. That's what the industry is going towards, right?
And why are we good partners for the hyperscalers? Well, the strategy of bringing the cloud down to the edge is what they're good at, and actually what they're built for and optimized for, and quite frankly, probably the best in the industry, right? And I think there's been challenges when IoT platforms try to be everything vertically as well as horizontally. We will never be as efficient as Azure or Google or Confluent at processing data in large petabytes of scale, right? And that problem, which their cloud infrastructure and their public companies are solving for, they're just going to be better at it. Well, it's the opposite. They're terrible at things like IoT sensors and taking from heterogeneous systems. And I think it's a realization where that line is, and they'll probably try again sometime in the future. Another swag at it. But just like Android and Google didn't build every app that's in the Play Store, or Apple doesn't build every app in the iPhone store, they realize that is where the breadth of the value comes from the operating systems, and that's where other companies and other developers really are important. It's the two-sided marketplace. If it wasn't app developers building the apps, then Google and Apple would have to build it. I think the same thing with the sort of landscape of IoT, and sort of as you go from the big cloud to smaller clouds and to the far edge. That's really their sweet spot, and will continue to be the sweet spot, which is
Yep.
good for companies like Goliath.
Yeah, I appreciate. I'm a strong believer in that as well. And well, look, you use the. We won't talk too much about that, but you use the mobile analogy or symmetry. I think the where the mobile world landed is like in this like big like two-headed monster that is kind of like not really open to the concept of ecosystem, while our domain IoT is actually an ecosystem story. It's not a one or the other in one solution versus another one. It's really about the right bits and pieces to be put together for a specific scenario and implementation. And this is what I really love about this kind of conversation we're having, is because we're starting to define what the level of granularity looks like and what this ecosystem looks like. And we're seeing a refinement at all levels, the device connectivity aspects of things, the data management, data ops at the edge is something that I've been inviting a few people from HighByte or Litmus and topics that I'm discussing here and there. And ecosystem first. And I think this is really the right play here, rather than trying to do it all. So focus on your, not a niche, but your domain, and be compatible with the others. Play nice, basically.
You actually made me think about something that we didn't discuss before, and it's one of the topics we talk about internally. Like, why is IoT different than, let's say, laptops and cell phones and servers? Because we all agree, and anyone who works in it's like, oh yeah, they're different. And there's this distinction about who owns the device, who operates the device, and where does that device live. And it's kind of acute for me from my time at Nest. Nest Thermostat, obviously managed by Nest Engineering and Nest Cloud, but it was a consumer device. It was in your home. What happens when you want to sell that to hospitals or hotels? Who's the owner and the operator of that device? It was actually a challenge for, at least when I was there, to get into hospitality, because the guest who's staying in the room is the temporary resident, and when they leave, it's the manager, and there needs to be an override. And all this data modeling complexity that we had at the time didn't match that, and maybe they've solved it since then. But with every IoT device, those questions are top of mind. If it's consumers is a whole other category, but are you a construction tech company that the construction workers will be using? Or are you the construction tech company who is operated by operators who are employees of your company? Is it in the middle of nowhere? Is it in an office building? And so all these pieces make it even more complicated to reason through and determine, where, what kind of solutions you have, where does the data live, who owns the data, things about privacy for that matter, which, just makes it the necessity to have an ecosystem and a compatibility layers and working together, just because there's just no one silver bullet that goes through all of it that makes it all work.
Yep, agreed. So we could go at it for hours, I'm sure. So we'll leave it at that. What do you recommend someone wants to learn more about Golioth to do next?
Go to our website. We have an individual developer tier. It's free to use, and you can get started today. If you have devices, we support a wide range of microcontroller devices with everything from, we talked about cellular, but a whole bunch of accessible ones. We even have a simulator now, so you can try without having a device in hand to send some sample data. And we have a community. So we have forums where users as well as our customers hang out. And if you're looking for a commercial solution and working with us, you can find me on LinkedIn, which I'm sure we'll have my link there, or talk to one of our sales people.
We'll bring it down there.
Down there.
Awesome. Cool, Jonathan. So people will definitely go down there. Thanks a lot for your time today. Interesting conversation. Definitely follow-ups. I'm sure at some point we'll have you back here. And I look forward to, see what people do and how they react to Golioth. So thanks everyone for tuning in. Thanks, Jonathan, again for joining us today.
Thanks for having me. Cheers.